Water vapour spreads out into the atmosphere. It's carried by the wind, but it can also spread out of its own accord by a process known as diffusion. Invisible gases behave in the same way. The particles in a gas move randomly in all directions. This helps explain why a gas diffuses from one place to another. You can see diffusion happening on a small scale in the lab, using bromine, an orange-coloured gas. Place a jar of air on top of the bromine, and it slowly starts to spread. It's moving up the tube against gravity. Over time, the two gases mix. After half an hour, both containers have a uniform colour. It takes time because the air and the bromine molecules are colliding with themselves and each other. So what would happen if there was no air for the bromine to bump into? All the air has been removed from this apparatus, apart from the flask containing bromine, which is isolated by a tap. Open the tap and it spreads immediately. Watch again. In a vacuum, there's no air to collide with. The bromine diffuses much faster. See how slow the diffusion is when the flask is now full of air. It takes several minutes to get just this far. This simple setup can be used to compare the rate at which different gases diffuse into air. Nitrogen dioxide gas on the left is similar in colour to bromine on the right, but bromine molecules are much heavier. The lighter nitrogen dioxide diffuses more quickly. We can also compare the diffusion rates of other gases. Ammonia and hydrogen chloride gas are colourless, but when they meet, a white cloud of ammonium chloride forms. A piece of cotton wool soaked in concentrated ammonia solution provides ammonia gas. Concentrated hydrochloric acid provides hydrogen chloride gas. Place the two pieces of cotton wool at opposite ends of a tube and the gases spread out. You can compare the speed at which they approach each other by looking out for a cloud of ammonium chloride. After less than a minute, a white ring begins to form, marking where the gases meet. The white solid is closer to the hydrogen chloride end of the tube, on the right. So which gas has travelled faster? Another way of monitoring the progress of the gases is to run a piece of damp indicator paper along the tube. Hydrogen chloride gas turns it red, ammonia turns it blue. Why does ammonia travel faster? Diffusion also happens in liquids. These three tubes containing water are immersed in baths at different temperatures, 0, 20 and 70 degrees Celsius. A crystal of potassium permanganate is placed in each. After 10 minutes, diffusion in the hot water is almost complete. Why does the rate of diffusion appear to be quicker at higher temperatures? What other factors might be involved?